Welcome back. This is Rubright with Advanced Geometry. Today's lesson is 3.1, Identify Pairs of Lines and Angles. Think of each segment in the figure as part of a line. Which lines or planes in the figure appear to fit the description? Lines parallel to line CD and containing point A. What's parallel to CD containing point A? Parallel to CD containing A. What? Line AB. Right? So it says AB. Oh, well, actually, there's more than just one, right? Because line AB, line HG, and line EF are all parallel, but only one of them also contains point A. So it's only this one. Does that make sense? So there's three lines that are all parallel, but this is the only one that contains point A. All right, so now the next one. They want to know line skew to CD, to line CD, and containing point A. Skew to CD containing point A. Skew lines. So parallel lines never intersect, right? Skew lines, they never intersect. They are not on the same plane, and they are not parallel. Skew lines never intersect. They are not on the same plane, and they are not parallel. Skew lines never intersect. They are not on the same plane, and they are not parallel. So skew lines to CD. So we know that it is not these, because these three that we just had highlighted are parallel, not them. They cannot intersect, right? They cannot intersect. So it cannot be this one or this one, this one or this one, right? So going with the roof, it can't, no, 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 because parallel, intersect, intersect. How about the front wall? Intersect, intersect, this one works, right? Going up and down versus over here, they are not on the same line. They will never intersect. They're not on the same plane. Those, they're not parallel. Those are skew. So not skew, not skew. How about this one down here? That's skew to this, right? So we have two skew lines so far. How about the side wall? Intersect, intersect, parallel. No. Back wall. Intersect, intersect. This one will work. This one will work. How about this side wall? Parallel, parallel. Yes, yes. And this one will work too. So we have line EH, line AH, line BG, and line AG are skew to line CD. Which one contains point A? So if we're doing the ones that only contain point A, we have AG and AH. Make sense? Lines perpendicular to CD containing point A. Perpendicular lines. Perpendicular lines intersect at 90 degrees, right? Perpendicular to CD containing point A. Well, there's really only one, right? Line AD. So lines BC, AD, DE, and FC all are perpendicular, but the only one that contains A is AD. Planes parallel to plane EFG containing point A. EFG. Where's EFG? EFG, the floor. What planes are parallel to the floor? What's parallel to the floor? The ceiling. Plane DAB or ABC, however you want to name it. Pick three of the four letters. The given line markings show how the roads are related to one another. Name a pair of parallel lines. So a pair of parallel lines. You guys see these little tick marks saying, hey, dude, we're parallel. Do you see these little arrows? There's two arrows and two arrows. Those arrow marks say we are parallel. So line MD and line FE are parallel lines. There is no need to pack up. I have 6 minutes. Thank you. Name a pair of perpendicular lines. Perpendicular lines intersect at 90 degrees. So a pair of perpendicular lines, do you guys see this little faint blue box? Your textbook publishers did a really, really fabulous job of making it very faint. Right here. That's saying, hey, we intersect at 90 degrees. So line BF and line MD are perpendicular lines. And then is line FE parallel to line AC? Is FE parallel to AC? They do not look anywhere near parallel, and absolutely not, because it's parallel to MD. And can only be like line FE can only be parallel to one line through the same point, right? Because we know that's parallel to this, and this is a different line through that point, so they're positively not parallel. So FE is not parallel to AC because MD is parallel to FE, and by the parallel postulate, there's exactly one line parallel to FE through point M. Look at the diagram in example 1. Name the lines through point H that appear to be skewed to CD. Lines skewed to CD through point H. So through point H, well, we have 1, 2, 3 lines through H. Is this one skew? AH? Yeah. Not in the same plane, not going to intersect. All right, how about GH? Nope, it's parallel. Can't be parallel. How about HE? Is HE skew? Yes, it's never going to intersect, not in the same plane, not parallel. In example 2, you can use the perpendicular postulate to show that line AC, I know these arrows are not really drawn well, line AC is not perpendicular to line BF. So use the perpendicular postulate to show that AC is not perpendicular to BF. Well, line MD is perpendicular to BF through point M, therefore any other line through the same point cannot be perpendicular, right? All right, so now we are going to get into some more vocabulary because vocab is so fun. So, corresponding angles. Corresponding angles are in the same side, same position. So, when I say sides, I'm talking about the transversal. So, do you see this line cutting through two parallel or non-parallel lines? A line cutting through two parallel or non-parallel lines is called a transversal. I'm doing that with the mouse. I should probably use my pen. That is a transversal. A line cutting through two or more lines is called a transversal. Okay? So corresponding angles. Corresponding angles are on the same side of the transversal in the same position. So like 1 corresponds with who? 1 corresponds with who? Above the transversal to the left of the line, above the transversal to the left of the line. 1 and 5. 2 corresponds with above to the right, 2 and 6. 3 and 7, good job. 4 and 8 are corresponding, good. How about alternate interior angles? Alternate interior angles, alternate, opposite sides of the transversal, interior, inside the parallel or non-parallel lines. So inside of these, opposite sides of the transversal. So like 4 goes with 5. 2 goes with 7. Do not pack up. Alternate exterior angles. Opposite sides of the transversal. Exterior, outside the parallel or non-parallel lines. So like 3 goes with 6. Opposite sides of this transversal. Exterior, outside the parallel or non-parallel lines. Give me another pair. 1 and 8. Good job. Consecutive interior, same side inside. Consecutive interior angles, same side inside, same side interiors. 4 and 7, same side inside. 2 and 5. Name, what are these? What are 1 and 5? Corresponding, good job. What are 2 and 7? Alternate exterior, opposite sides of the transversal, exterior, outside the parallel or non-parallel lines. How about 4 and 5? Alternate interior, opposite sides of the transversal, inside the parallel or non-parallel lines. And that is everything. I hope you guys enjoyed your lesson on 3.1, identify pairs and lines of angles. Please like and subscribe and have a great day. You guys can pack up.